Hermeus has officially taken flight with its Quarterhorse Mk technology demonstrator, marking a significant step toward its goal of deploying a fully reusable, uncrewed, hypersonic aircraft. What does this mean for the future of aviation, and will it be able to deliver payloads at hypersonic speeds for a fraction of the cost of hypersonic missiles? Let's find out. Announced on May 27th, the Quarterhorse Mk first took to the air at Edwards Air Force Base, California, when it achieved stable flight and landed smoothly, according to the company. A video released by Hermeus appears to show a takeoff and then a brief period in the air, followed by it setting down shortly after on the Edwards lake bed. Mk 1's flight validated our rapid, iterative approach to airplane development and advanced our mission to radically accelerate aviation, Hermeus added. Among the byproducts of this approach is the relatively rough external finish of the Mk 1 aircraft. A first flight for the Mk 1 flying prototype had been planned for some time toward the end of 2024. It's unclear why this timeline slipped. The Mk1 was preceded by a dynamic Iron Bird test rig, also known as Quarterhorse Mk. This non-flying prototype was used to validate major aircraft subsystems, including in taxi runs at the Air Force's Arnold Engineering Development Complex, AEDC, in Tullahoma, Tennessee. Throughout the project, Hermeus has stressed rapid, iterative development and prototyping. The non-flying Quarterhorse Mk was built in just 6 months, and all its test objectives were completed in 37 days of testing. Now, with the Mk 1, Hermeus says it went from clean sheet to flight ready in a little over a year. As part of this effort, the company is building 4 Quarterhorse aircraft of successively greater complexity and scope. The Mk 1 aircraft was built to verify takeoff and landing of an uncrewed aircraft in this configuration and is not apparently planned to trial high-speed flight. It is powered by a General Electric J-85 turbojet, as used in the Air Force's T-38 Talon jet trainer, for example. Other aspects of the flight test program for the Quarterhorse Mk 1 are examining aerodynamics, stability, and control. Testing of the Mk 1 is also intended to validate various subsystems, including propulsion, fuel systems, hydraulics, power, thermal management, avionics, flight software, telemetry, flight termination, and command and control. The Mk 1 will be followed by the Quarterhorse Mk 2, intended to reach supersonic speeds below Mk 3. Currently, the Mk 2, which will be around the same size as an F-16, is in production at Hermeus's headquarters in Atlanta. The company says it should fly before the end of this year. This will be powered by a Pratt & Whitney F100 turbofan engine, also used in the F-16. Finally, Quarterhorse Mk 3 will hit speeds beyond Mk 3 and, as Hermeus states, demonstrate turbojet to ramjet mode transition in flight and break the all-time airspeed record held by the SR-71. Notably, the Mk 1 that is now embarking on the flight test program is not the same vehicle as the prototype that Hermeus rolled out in November 2021. This vehicle lacked any obvious flight control surfaces or landing gear, but did feature a functioning engine with afterburner as seen before. At the heart of the Quarterhorse series will be a so-called Chimera turbine-based combined cycle (TBCC) engine. This engine could be thought of as 2 engines in one, a J-85 turbojet followed by a ramjet. Turbojets are adept at powering aircraft from a complete stop and up to around Mk 3, though their efficiency tends to drop off at speeds above Mk 2. Ramjets take over at high speeds, accelerating from Mach 3 to hypothetical speeds as high as Mach 6. Chimera's ramjet is designed to accelerate Quarterhorse past Mach 4 and potentially even beyond Mach 5 at altitudes as high as 95,000 feet, both faster and higher than the SR-71 could fly. Hermeus successfully demonstrated Chimera's ability to transition from turbojet to ramjet power in a high-speed wind tunnel as early as November 2022, but Quarterhorse Mk 3 will be the first aircraft in history that we know of to demonstrate this functionality. Hermeus says Quarterhorse will be able to achieve hypersonic speeds, typically considered anything above Mach 5. At these speeds, over 3,000 miles per hour, flight times from New York to London will be 90 minutes rather than 7 hours, the company's press release says. Mach 5 aircraft have the potential to create an additional $4 trillion of global economic growth per year, unlocking significant resources that can be utilized to solve the world's great problems. Yet Hermeus's plans do not end with Quarterhorse. With the lessons learned throughout this effort, Hermeus will then begin development on its Dark Horse hypersonic military aircraft that will be powered by 2 larger Chimera engines developed around the powerful and proven Pratt & Whitney F100 turbofan engine. To that end, Hermeus broke ground on a new hypersonic engine test facility in Jacksonville, Florida, in September 2024. This facility, dubbed the High Enthalpy Air Breathing Test Facility, or HEAT for short, will allow Hermeus to rapidly iterate on both aircraft and engine design. Though Hermeus's Chief Revenue Officer, Zach Shaw, also mentioned that company's own testing won't fill the facility's entire testing schedule capacity. This will allow the company to sell test time to other firms or even the Air Force itself for any of the reported 70 or so hypersonic weapon and aircraft applications currently drawing funds from the Pentagon's coffers. This is very important in the realm of hypersonic aviation, as some of America's biggest challenges in recent years when it comes to hypersonics has been a lack of sufficient testing infrastructure, compounded by the need for more raw data about how designs perform in the hypersonic regime. Once complete, Dark Horse could provide the U.S. Air Force with a similar high-speed intelligence, surveillance, and reconnaissance capability once provided by the SR-71, a capability that is sorely needed despite America's increasingly ubiquitous satellite infrastructure. But maybe even more importantly, Dark Horse could deliver payloads to far-flung targets at speeds in excess of Mach 5, providing the same short timeline and immense kinetic power of a modern hypersonic missile, but at a fraction of the cost per strike. In keeping with Hermeus's rapid iterative approach, the company says its slightly larger Mach 2 Quarterhorse supersonic demonstrator is already on track to fly later this year, which is an all but unheard of timeline. As Hermeus's CEO has explained in the past, the aviation standard for new designs is roughly 1,400 days, or around 3.5 years. At this pace, Hermeus will have fielded and tested 3 aircraft in roughly the same amount of time. And what do you think about it? Share your thoughts in the comments below. Also, if you enjoyed this video, don't forget to like it and subscribe to the channel and turn on notifications to always stay in touch. And thanks for watching.